gentlemen? It's quite a big topic on right angled triangles. Your test is up here on the 24th of May. It is a topic that has two main sections. The first one that we're starting with today is Pythagoras' theorem, which you have seen before and hopefully you remember. Normally people find that part the easiest because you've seen it before. And then there's a completely new section to do with right angled triangles that we call trigonometry. And once you get the hang of it, it's lots of fun, I think. Very important part of this topic. We'll be spending a lot of time on that. So today though, we are just focusing on the Pythagoras' theorem part. So let's go through that. So Pythagoras' theorem is one of the oldest and most commonly known mathematical relationships. It only applies to right angled triangles. Don't ever try and do it to a non-right angled triangle. Do we need to move? No. Then you will not speak to each other again. You're closed, mouth closed, you're listening. The longest side of a right angled triangle is always called the hypotenuse. I don't know why they decided to give it such an unusual name, but there it is, hypotenuse. The other two sides, which sometimes you call them the legs or the arms, the other two sides, we just call them A and B. Okay, so on the two triangles that are there, we're going to practice putting the names or the labels on those triangles. So I'll do the first one and then you have a try. The first thing you want to do is find that right angle. So here it is, right angle. The A and the B are the two sides that join on either side of that right angle. Doesn't matter which one's A and which one's B. I could have swapped them around if I wanted to. The hypotenuse is always the one straight across from the right angle. It's the longest side, and I'm just going to put a big H on it, capital H for hypotenuse. So can you try and do the second one, please? Can you label the A, the B, and the H for hypotenuse? Do you have a pen, Clayton? Yeah. Write them down, A, B, and H for hypotenuse. Where are they going to go? It seems simple enough, but if you don't get the labels right, then you're going to mess up your Pythagoras theorem. So it's very important that you get the label part right. Okay, so hopefully you've got A and B as those two sides. Doesn't matter if you write them the other way around. And H for hypotenuse is that one there. Did everyone get that? Great. So there's a little section here in our booklet called Discovering Pythagoras' Theorem. I don't want to spend too much time on this because I want to focus on actually practicing Pythagoras' theorem. But briefly, this is how Pythagoras was discovered. So it says here, using a ruler, measure the sides of the following right angle triangle. Do you guys have rulers? You've got one? Oh, let's see how many I've got in here. Oh, I've got one. That's not going to work, is it? Alright, no, it's just a brief thing I'll tell you, okay? So if you measure this side here, it works out to be 5 centimeters. Okay? Now, if you were to draw, it says in step 2 there, draw a square of each of the 3 sides. So if you have a straight edge of any kind, you could try to approximate this. You have a square, you want to draw a square coming out from there. So it'd be 5 centimeters long each way. That's not to scale, but anyway. If that was a lovely, accurately drawn square, what would the area of that square be, Anton? 5 centimeters. No. How do you find the area of a square? Well, maybe you should stop talking then and actually pay attention. The area of a square is found by timesing the side length. If it's a square, it's 5 centimeters by 5 centimeters, which means that the area of that would be 25 centimeters square. Now this side over here, if you measure it, that's 3 centimeters. If you were to draw a square off of that, what would its area be? 3 times 3 is 9. This one down the bottom is 4 centimetres. 4 times 4 makes 16. Now, if you have your calculator there, can you see a pattern? If you add together 9 plus 16, what do you get? $25. So what I've done, 3 squared plus 4 squared gave me the 5 squared. And that is Pythagoras' theorem. That is the rule that we get right. Oh, where is it? Way down here. There it is. The hypotenuse squared is always equal to the a squared plus the b squared, the two shorter sides, squared and then added together. So you've got Homer Simpson in there. I don't know if you guys ever watched The Simpsons. You probably do. Do you guys ever watch that? Yeah. You did? Yeah. So there was an episode, I remember watching it ages ago, where he was actually smart for a day because he could do Pythagoras' theorem. So that's why that's there. All right. So that's the formula. H squared equals a squared plus b squared. Now, before we use it, here is some extra practice labeling. So I want you to have a go again. You can do these ones. It just says label the hypotenuse with the letter H. So first one, there's the right angle. The side across is a H. Go through and put H's on all the ones that are the hypotenuse across from the right angle. Next page, doing what I've asked you, please. Yep, label that hypotenuse. Cross from the right angle, H for hypotenuse. Should take 30 seconds. Go, go, go. Clayton, do you know what to do?
Yeah.
All right, so write some H's on there, please. Cross from the right angle. We'll practice. You can put the A and the B on there as well if you like, but the question just asks us to put the H on for the hypotenuse. Done? Wonderful. All right, so there, done. Hopefully you got the same thing as me. Today we are going to be focusing on finding that hypotenuse. All the questions are going to be finding that hypotenuse. Now, the one that I showed you before, the h squared equals a squared plus b squared, that is the formula, but it's actually much more useful to have the h by itself without the squared there. So this one here is the one I'm going to be using in the examples, and it's the one I want you to write on your study sheets or memorize, even better. Okay? All that happens, if this was h squared here before, to get rid of the square, you square root the other side, which is why this big square root comes in over this side. It's just the same formula, I've just square rooted to move that across to the other side. So, when you see a question like these ones here, and you can see that the side, the letter here, I'm trying to find out what h is, I'm trying to find the hypotenuse. As soon as you see a question, you go, oh, I'm trying to find out what the hypotenuse is, you write that formula down. So everybody, write that formula down. H equals square root of a squared plus b squared. The a and the b are the two short sides here. Let's put the labels on there. A is going to be 6 and b is going to be 8. Everybody should be writing this down. Now, my second line of working is going to be to substitute those numbers into my equation. So I can just do equal signs underneath each other. I don't need to keep writing the h. You can if you want to. But if you put the equal signs underneath each other, you don't need to keep writing the h. Square root of a is my 6. It's going to be 6 squared plus b is the 8. So 8 squared. Okay, and then there's going to be a third line. It's going to be 3 lines. Yeah, well. Does the order matter? No, it doesn't. Correct. Not for this one. When we do the shorter side, it will matter. The third line is to calculate what that equals. So this is where we grab our calculator out. And we go square root button. Can everyone find that button? 6 squared. Do you know where the squared button is? plus 8 squared, and then press equals. I got 10. Did everybody get 10? Wonderful. So the answer is 10. But not only 10, that is the length of this side, and a length should always have units. The units are centimeters, so it's 10 centimeters. Okay, so those 3 lines are the 3 lines I want you to show for every single question. Let's do it again. Question 2, I'm finding the hypotenuse, which is going to be this one over here, the x. The A and the B are these 2 shorter ones. Does not matter which one is which, but I've labelled the A the 12 and the B the 9. For the working out, the first step is always to write the formula down. H equals big square root of A squared plus B squared. Now, because they've used a different letter other than H here, on the second line, you should put x equals, because I'm actually finding x in this problem. And now I substitute in my numbers. So A is 12, so 12 squared plus B is 9 squared. Okay, and grab your calculator, type it in. Square root 12 squared plus 9 squared. It's 15. 15 meters this time. Easy, right? Couple more here for us to do. Question 3. How about I let you get a head start? Label your H, your A, and your B. Write your formula down and see if you can start substituting in. That doesn't mean colour in the page, Anton. It means do the question, please. And you should have at least copied down questions 1 and 2. Okay, I'm not sure if you've quite finished yet. Keep going if you know what you're doing. But I have started. The H is where the K is, the A and the B I've labelled those, and I've written my formula down. Second step, instead of H, it's going to be K, so I change that letter there, because K is what I'm trying to find. Big square root sign, A is 2.5, and I put a square on that, plus B, which is 6 squared. And in the calculator, square root of 2.5 squared plus 6 squared equals 6.5 millimeters. Yeah, well, then you'll have to round it. So in the worksheet that you're going to do, it says to round to 1 decimal place where necessary. So we'll do the same thing for the next one. Question 4. There is a slight little problem with this question. Can anyone see it? That's right. Well done. This one's in millimeters and this one's in centimeters. You always need to have them in the same units before you can use your Pythagoras theorem. So it doesn't matter, unless the question says, some questions will say, find H in centimeters or in millimeters. If it says, then you obviously have to change it to the one that asks you for. If it doesn't say, you can choose which way you want to go. Do I want them both to be in millimeters or do I want them both to be in centimeters? What do you guys want to do? Centimeters, okay? So this one's already in centimeters. What is 18 millimeters in centimeters? Say again? 8, that's right. So I'm just going to circle that and go, instead of 80, I'm going to go, that is actually 8 centimeters. So we're going to use that measurement instead. The A and the B are going to be those 2 numbers, and the H is already on there. First line, write the formula down. H equals square root of A squared plus B squared. Second line, big square root. Sub in the numbers. A was 7 and B is 8. Third line, type it in the calculator. Square root 7 squared plus 8 squared equals. When you get a decimal, like I was just saying with Will here, your worksheet is going to say to round to 1 decimal place. So that means there's my decimal point, there's my 1 decimal place is the 6. Anything after that rounds off, which means that 3 is the critical digit. Because it is less than 5, it just chops off, okay? So it's going to be 10.6. 10.6 centimetres. And that's it. That's Pythagoras' theorem to find the longest side, to find the hypotenuse. So here is your worksheet on the next page, page 5. Any rounding due to 1 decimal place. All right, get started on that, please.